Hello friends, welcome back to my channel, and today's our theorem is the vice versa of the theorem which we studied earlier. The statement says the line drawn through the center of the circle. Line drawn through the center of the circle. That means our line OM is drawn from the center of the circle. Bisects the chord. Bisect the chord means in this case our chord is AB and this line OM bisect our chord AB. That means our AM will be equal to MB. As you can see over here, in this case, we are clearly given that our AM is equals to MB. In the earlier theorem, this thing which we have to prove. In earlier concept, we have to prove that AM is equal to MB. Now, it is already given that AM is equal to MB. Okay. And the chord is perpendicular to the chord. That means now the case over here is we need to prove OM is perpendicular to AB. So let's start with our data. Data means the thing which is already given to us and which we can clearly see from the figure. In this case, we can see that AB is our chord. So you will write AB is a chord of a circle with center O. Okay, of a circle with center O. Okay, and what thing you can see that the line passing which line? Your line OM, that the line passing through the center the line passing through center O bisect the chord at M. Okay, bisect the chord at M. That means we can say that our AM is equals to MB. Clear? This much is given in our data. Now comes your to proof. Okay, so for to prove, here we need to prove that OM is perpendicular to AB. So simply write my OM is perpendicular to AB is the thing which we need to prove. Let's start with proof. How we are starting? We are taking two triangles, triangle OMA and triangle OMB. So write down, we are taking triangle OMA and triangle OMB. Okay. Now we know that OA and OB is the radius of both the triangles. So simply write that OA is equals to OB. What is the reason? Because they are the radius of the circle. Because they are the radii of same circle. Which you can clearly see that both the triangle are having same radius. In both the triangles, what is common? My side OM is common. So you will write OM is equal to OM as a common side. Okay. So write common side. Written. Then what thing which we know already from the data? We know that our AM is equals to MB. So write down my AM is equals to MB, which is given in our data. So write the reason given. Hence your triangle, therefore your triangle OMA is congruent to triangle OMB. Clear? Now, which rule we have used? We have used this side, against side and side. That means we have used S congruence rule. Okay, we have used S congruence rule. Now, what we will get in CPCT? So, as we are taken all the sides similar, we will get our angle as common in CPCT. So, therefore, angle OMA is equals to angle OMB by CPCT. Corresponding parts of congruent triangles. As angle, we know that as angle AMO and BMO are equal and forms the angle of linear pair. As you can see, our angle OMA and OMB forms the linear pair. So, their summation will be equal to 180 degree. Now, we know that angle OMA plus angle OMB is equals to 180 degree because they forms the linear pair. So that means if we divide 180 by 2, we will get our angle OMA is equals to angle OMB is equals to 90 degree. Hence, therefore, OM, we can say that OM is perpendicular to AB. Hence, proved. Thank you so much for joining. Hope you understand. Join again for the next video. See you next time.